Now let's compare these two quantities here. Let's compare the probability of A given B versus the probability of B given A. So they look real similar, but they can have very different values. And to illustrate that, let's consider a situation. And Paul goes through and describes this and attributes A to an accident, a death on the Bay Bridge, given a magnitude 8 earthquake in the Bay Area. Let's bring this a little bit closer to home. So let's say A is a power outage in Honolulu. Well, let's say Manoa. And B is a hurricane in Honolulu. Well, that hits Oahu. Okay. So the probability A slash B is the probability of a power outage in the presence of a hurricane, and probability of B given A corresponds to the probability, oops, I just misspelled probability there, probability of a hurricane given a power outage. So the second is, just suppose, power outages happen here and there occasionally, and pick one occasion, and what's the probability of that occasion being a hurricane? The first is, given that there's a hurricane, what's the probability of a power outage? And so you might imagine that the first is a lot more probable. And let's illustrate why that might be. So if we use Bayes' theorem to describe the probability of a hurricane given a power outage, the relationship to the former is okay. I'm going to talk about the second case first. So again, we're trying to understand the relationship between these two quantities, and it's really the ratio of PB over PA is what causes the difference between these two, right, in this equation. So PB over PA represents the probability of a hurricane divided by the probability of a power outage. So luckily there have been no hurricanes on Oahu in the past many decades, but of course we've had many power outages in Manoa. So this quantity is a lot less than 1, right? So that means the probability of a hurricane given a power outage is a lot less than the probability of a power outage given a hurricane. We can expect the probability of a power outage given a hurricane to be a lot bigger. Okay, so let's look at the first equation that I wrote down on the left. So we might refer to this, PA, we can refer to that as the prior probability. Okay, so this is the probability for all cases, whether there's a hurricane or a flood or just a power outage, right? So the probability of a power outage, okay, is different than the probability of a power outage given a hurricane, and you might expect this to be a little bit higher. Okay, there's probably a high probability of a power outage during a hurricane, and so you can think of the term here in square brackets as increasing the probability from the prior probability. Okay, so this is the effects of the hurricane to increase the probability of a power outage. Okay, this is the support of a hurricane for a power outage. So these are just different ways of interpreting these equations and relating these two conditional probabilities. Now, more generally, we can describe, well, we can generally, the prior probability A is the related to all possible causes of power outages, or all possible causes of A. So this is a more general, sort of a general description of the probability of A for all possibilities. And so the general Bayes theorem can be written: the probability of Bj given A is equal to the probability of A given Bj times the probability of Bj, B being lots of causes for A, divided by, and we'll just replace PA with the sum that we wrote out. Okay, so that's Bayes, general Bayes theorem. That says Bayes.